Hi, in this video we'll understand the application of the principle of flotation in our daily life. So we'll understand the application of flotation law. This is flotation law in our daily life. Now, flotation law is applied in our daily lives, such as it is used in a hot air balloon. It is used in a hot air balloon. It is also used in ships and submarine. Ships and submarine. It is also used in a hydrometer. So this principle is basically applied in these categories. So we discuss one after another, starting by the application of the flotation law in hot air balloon. So what is a balloon? A balloon, it is just the device which is made to float on air. It is just the device which is made specifically so that it can float on air. So it is construction, it basically looks like this. This is the hot air balloon. It is an example of hot air balloon. So it consists of the passenger. Inside here there is a passenger who are having the weight. So we are having the weight of the passenger. Let's say it is mass of the balloon times gravitational force. That will be the weight of the passenger and the other objects that will be inside that balloon. But also inside the hot air balloon there is different gases. For instance, helium is normally used. So we can say also there is the weight of the helium gas, which is obtained by taking the mass of the helium times the gravitational force. It is the weight which now will be acting downward. So what happens here? Basically, the hot air balloon, in hot air balloon there is gases. As I told you, there is helium gas. Now this helium gas is heated to the higher temperature. So as it heated to the higher temperature, the balloon tends to expand. It becomes large. It expands. So as the balloon expands, it means its volume also increases. As the volume increases, it means the density becomes low. Remember, density is mass divided by volume. So if you increase the volume, automatically you reduce the density. So the density now inside the hot air balloon is very small. All right? And also this balloon is surrounded by the air. In the surrounding there is air. And this air, it acts as the fluid which displaces the portion of the atmosphere. So there is the existence of upthrust due to the difference in density, because in the surrounding there is a density of air. So this difference in air between the inside of the balloon and the outside where there is air, it basically creates the upthrust. It creates the pressure which makes the balloon and the other objects to move into the air. You understand? That's what happened. So now you can adjust this balloon either to move on air or to move downward by changing the temperature of the gas inside the hot air balloon. In order to make the hot air balloon to move into the air, what you are required to do is to increase the temperature. As you increase the temperature, you reduce the density. As the density becomes very small, it means this hot air balloon can now move into the air. All right? If we want this balloon to move to the ground, you have to decrease the temperature of the gas inside the hot air balloon. As you decrease the temperature, you increase the density. As the density becomes large, it means the hot air balloon now will move to the ground. That's what happened. So let us take the example which indicates the hot air balloon which is neither moving downward nor upward. This is the hot air balloon, and we are having the mass of the balloon with the weight of the balloon which is acting downward. It is mass of the balloon times gravitational force. We are having also the weight of the helium gases which is also acting downward. So we are having the mass of helium times gravitational force which is acting downward. So there is force which is acting up, which is the buoyant force, the buoyancy force. So we are having the buoyancy force which is now acting upward to displace the portion of the atmospheric air. So if we consider that the balloon is neither moving upward nor downward, it indicates that the buoyancy force will be equal to the summation of the weight of the helium and the weight of the balloon and its contents. So we can say at stationary, when the balloon is neither moving upward nor downward, the buoyancy force, this will be equal to the weight of the helium, which is mass of the helium, times gravitational force, plus the weight of the balloon and its contents, including the passengers. So this is mass of the balloon times gravitational force. But what is buoyancy force? I told you that this buoyancy force will displace the portion of the air, because in the surrounding there is air. So this buoyancy force will be equal to, we'll take the mass of air times gravitational force. You understand? And the mass of air, this will be equal to the density of air times the volume of air. That is mass of air. Now we can substitute here that buoyancy force, this will be equal to mass of air, this is the density of air times volume of air times gravitational force. Now from this equation here, we can substitute buoyancy force by writing this density of air times volume of air times gravitational force. So density of air times volume of air times gravitational force, this is equal to mass of helium times gravitational force plus mass of balloon and its contents, including the passengers, times gravitational force. So we can cancel out gravitational force, because it is the same. As a result, density of air times volume of air, this will be equal to mass of helium plus mass of the balloon and its contents, including the passengers. Now, we also understand that mass of helium can be obtained by taking the density of helium times the volume of helium. So let us substitute here. Density of air times volume of air, this will be equal to density of helium. Instead of writing mass of helium, we can write density of helium times volume of helium plus mass of the balloon and its contents. Now, what happens here, the volume of air, this will be equal to the volume of helium, because the volume of object is equal to the volume of the displaced fluid. In this case, the displaced fluid, it is the air. The air, it acts as the fluid. So we can write V. Volume of air is volume of helium. It is the same. So we can substitute here. Density of air times volume, this will be equal to density of helium times volume of helium is the same volume plus mass of the balloon. Now we can take this on the other side of the equation. Density of air times volume minus density of helium times volume. This is equal to mass of the balloon and it is contents. Now factoring out V, can factor out V. V bracket density of air minus density of helium is nothing but equal to mass of the balloon and it is contents. So we can find the volume by taking mass of the balloon, including its contents, divided by density of air minus density of helium. So this is the volume that will be required to make the balloon now move into the air. You take the mass of the balloon, you divide it to the density of air, you minus the density of the gas. So thank you for watching. Don't forget to subscribe. See you then.